What is FNIRS, functional near-infrared spectroscopy? Have you ever wondered how scientists can peek into the brain's activity without any invasive procedures? One fascinating method is called functional near-infrared spectroscopy, often abbreviated as FNIRS. This technique is a non-invasive optical imaging tool that monitors brain activity by measuring changes in blood oxygen levels in the cortex, which is the outer layer of the brain. So, how does it work? Functional near-infrared spectroscopy uses near-infrared light, typically in the wavelength range of 650 to 925 nanometers. This light is emitted through the scalp and skull, reaching the brain tissue. The reason near-infrared light can penetrate biological tissues is that they are relatively transparent to these wavelengths. The magic happens because oxygenated hemoglobin and deoxygenated hemoglobin absorb this light differently. Oxygenated hemoglobin absorbs more light at wavelengths above approximately 790 nanometers, while deoxygenated hemoglobin absorbs more light below this threshold. By measuring how much light is absorbed and scattered back to sensors placed on the scalp, FNIRS can estimate the relative concentrations of these two types of hemoglobin in the blood vessels of the cortex. These changes are directly linked to neural activity. When the brain is active, it requires more blood flow and oxygen, a process known as neurovascular coupling. This means that FNIRS can provide real-time information about brain activity based on blood flow changes. Compared to other neuroimaging methods like functional magnetic resonance imaging, which also measures blood oxygen levels, FNIRS has some advantages. It is more portable, less expensive, and can tolerate subject movement. However, it does have limitations, such as lower spatial resolution and the inability to measure activity deeper in the brain. Functional near-infrared spectroscopy is often used alongside electroencephalography, which records electrical activity in the brain, for a more comprehensive view of brain function. From the perspective of emerging computing technologies and bio-integrated computing, FNIRS is an important tool. It allows for functional monitoring of brain activity in natural settings, making it suitable for studies involving movement or populations like children and the elderly. The data collected through FNIRS can be analyzed using advanced computing techniques, including signal processing and machine learning, to interpret brain states and support technologies that adapt to neural activity. In essence, functional near-infrared spectroscopy is a fascinating and practical method for observing brain function, bridging the gap between neuroimaging and bio-integrated computing.